The wars in Ukraine and now in the Persian Gulf have shattered many of the usual rules of engagement. All sides in these conflicts are making prodigious use of drones, both on the front lines and for long-range strikes far behind them. A massive arms race has ensued, with nations around the world scrambling to develop the most deadly, scalable, and cost-effective attack drones with the utmost urgency. At the same time, an equally crucial arms race has emerged alongside: counter-drone technology. Also known as CUAS solutions, counter-drone efforts run the gamut from cheap handheld net guns to advanced missile systems that cost hundreds of millions of dollars. But now, Swedish giant Saab has come up with a unique concept that's been proven in action and may just change NATO's entire approach to anti-drone warfare: the Loki. So let's take a closer look at the Loki system, what makes it such an innovative concept, and how it could change drone warfare permanently. Now, CUAS has become big business. A spate of drone incursions into European airspace in mid to late 2025 exposed how unprepared much of Europe was for the kind of bombardment by drone swarms that Ukraine, and increasingly Russia, are being compelled to continuously fend off. Traditional missile-based air defense systems like the MIM-104 Patriot and the Iris-T have proven to be effective at taking out long-range drones like Russia's Shahed Joran variants. Effective, but not cost-effective. It's simply not feasible to use multi-million-dollar interceptor missiles to shoot down drones that cost tens of thousands, especially not when the drones can be produced at a rate of hundreds per day, while the interceptor missiles are produced at a rate of hundreds per year. So the race is on to develop CUAS solutions. Now, between 2026 and 2030, NATO members and close allies are expected to spend more than $210 billion on air and missile defense capabilities. Much of that will be allocated for high-end systems like Patriot, Iris-T, and Saab systems. The need to protect against high-end threats like Russian and Iranian cruise and ballistic missiles is as critical as ever. However, billions are also pouring into air defense systems specifically focused on drones, especially systems that offer a workable cost-to-kill ratio and are easy to produce in large quantities and quickly. The latest Unmanned Airspace 2026 Global Counter-UAS Systems Directory lists over 1,000 CUAS systems from more than 550 companies that are under development or in production around the world. The directory breaks the systems down into 11 different categories: systems for capturing drones, like net guns, uncrewed ground vehicles, detector systems, directed energy weapons systems, electronic countermeasures or ECM, guns, integrated systems, intercept drones, missiles, munitions, and others, including software. But unlike most of the systems listed, they might have difficulty slotting Loki into one single category or another. Because what makes this system special isn't some brand new high-tech way of bringing down drones or innovative use of AI. Rather, its beauty lies in pragmatically putting together abundant, existing components to create a highly effective and cost-effective system. Saab didn't try to reinvent the wheel. They didn't have to. Their engineers looked at existing components sitting on their shelves, designed for entirely different use cases, and realized they already had everything they needed to produce the ultimate drone killer. And it's a move that has CUAS designers around the world going either, "Hang on, why can't we do that?" or "Gimme." Now, the fact that it's Saab coming up with pragmatic and innovative solutions to pressing military problems should come as no surprise to seasoned observers of the global military-industrial complex. They've been doing it for decades, after all. The company, whose name is short for Svenska Aeroplan Aktiebolaget, or Swedish Aeroplane Corporation, was founded in 1937. It subsequently became the dominant defense industry company in Sweden, with a market cap in excess of $35 billion. It's by far the most important company in the country in terms of scale, technological innovation, and strategic importance. Over the years, Saab has consistently delivered a smorgasbord of weapons widely in demand around the world for their quality, practicality, and reliability. The most notable of these are probably the iconic JAS-39 Gripen fighter jet, AT-4 anti-tank weapon, RBS-15 anti-ship missile, Double Eagle mine-clearing naval drones, Carl Gustaf M4 recoilless rifle, Trackfire remote weapon station, and Giraffe radar systems. And the last two items on that list are now being combined in the brand new Loki system. Loki was first presented in February 2025, the fruits of a collaboration between the Swedish Air Force, the Swedish Defence Materiel Administration, or FMV, Saab, and other partners. It combines existing technologies into a modular system that can be assembled in different configurations, like Lego. The system integrates a mobile radar, Saab's Giraffe 1X, with a Trackfire remote weapon stationed, armed with heavy and medium machine guns, along with electronic warfare components. That means it can track both physical targets and signals in the electromagnetic spectrum, providing both early detection and multiple options for neutralization. Because of its modular design, other attachments, such as a directed energy weapon for example, could conceivably be attached with relatively little hassle in the future. More about those a little later. But for now, the known components of the system are all widely used across NATO member states and beyond, reducing interoperability and operator training learning curves to a minimum. Take the radar for example. The Giraffe radar family began development in the 1970s, with the first systems delivered in 1977. They were originally developed alongside the RBS-70 surface-to-air missile. Early Giraffe radars were mechanical, 2D, 3D pulse Doppler systems operating in the GH band and designed to detect low-flying aircraft in cluttered environments. Over time, the family evolved into advanced digital systems, culminating in the Giraffe Agile Multi-Beam, or AMB. The AMB is a 3D passive electronically scanned array, or PESA radar, that has been widely exported and used in both land and naval roles, as the Sea Giraffe in the latter case. But the real leap forward came in May 2014, when Saab unveiled the Giraffe 1X, the variant used in Loki. Perhaps with a nod towards the emerging field of drone warfare, this compact X-band active electronically scanned array, or ESA radar, marked a shift toward mobility, rapid deployment, and multi-role capability. The ESA array allows the radar to steer its beams electronically rather than mechanically. That means faster scanning, improved reliability, and the ability to track multiple targets simultaneously. The ESA radar also provides three-dimensional tracking, meaning it can determine a target's range, bearing, and altitude. This is critical when dealing with small drones or low-flying threats that can blend into ground clutter. In addition, advanced signal processing enables the system to distinguish real targets from birds, terrain, and weather effects, improving detection accuracy in congested environments. The result is that the Giraffe 1X offers 360-degree coverage with a full volume scan every second. It's sensitive enough to detect low, slow, small, or LSS targets like drones on top of its counter-RAM, that's rockets, artillery, and mortars, sense and warn functionality. The land variant has a range of around 47 miles, while the naval variant has a range of around 61 miles. More recently, the Giraffe 1X deployment set was added in 2023, improving transportability and readiness. And in 2024, the compact radar module was introduced, enabling the antenna to be folded into the housing at the press of a button. With a total system weight under 330 pounds, it can be readily deployed on light vehicles, masts, or rooftops to provide simultaneous air and surface surveillance. It can be operated either remotely or locally and offers flexible integration with command and control or C2 systems. In other words, it can be seamlessly linked with other sensors, communication networks, weapons platforms, and decision-making tools to enable coordinated military operations. With all those features, little wonder that demand for the Giraffe 1X has been high. The US, Sweden, Latvia, and the UK are all procuring the system, either to be used on light vehicles, tactical units, fixed sites, or integrated into naval platforms. Now, it's also the eyes and ears of Loki. That makes perfect sense. The Giraffe's characteristics are perfectly suited to a modular, mobile CUAS platform like Loki. Even better, with healthy demand from home and abroad for the various iterations of the Giraffe for almost half a century, Saab's production lines are well-oiled and its inventories are well-stocked. From Saab's perspective, for Loki, the Giraffe is pretty much an off-the-shelf solution. And it's more or less the same story with the weapon system that fires at the targets identified by the Giraffe. The Trackfire Remote Weapon Station, or RWS. Like the Giraffe, its choice was somewhat of a no-brainer for Saab. Trackfire is a remotely operated weapon and sensor system specifically developed by Saab for integration on naval vessels, fixed defense positions, and land vehicles, i.e. on platforms just like Loki. The system was publicly launched at the DSEI 2007 Expo in London and entered service in 2012 with Finland's Navy, its first major deployment. That was followed by a 2017 contract with the aforementioned FMV that saw the Trackfire integrated domestically onto combat boat 90s and other naval platforms. And at least 26 of those boats ended up in Ukraine. Since 2022, Sweden has sent Ukraine 21 packages of direct military aid, worth a whopping $11.3 billion. Included were donations of advanced weapon systems like Archer artillery, Stridsvagn 122 tanks, air defense systems, and CB-90 boats like Trackfire RWS. 10 CB-90s were delivered to Ukraine in February 2024 and a further 16 in January 2025. As it turns out, those Trackfire integrations were some of the last of the old configuration of the system. The new configuration, no doubt heavily influenced by Ukraine's experiences during the war, was about to be unveiled. The Trackfire Ares was also unveiled at DSEI, albeit at the 2025 edition. It's specifically designed for CUAS operations and is the perfect fit for Loki. Optimized for high precision and crew protection while firing on the move, it supports 360-degree azimuth rotation with elevation from -20 degrees to +55 degrees. Now, those aren't particularly impressive specs compared to rival RWS systems, which typically also have 360-degree azimuth. The naval variants of the Kongsberg Protector RWS and Korean Hanwha Defense Naval RWS have the same depression of -20 degrees, but a slightly higher elevation of +60 degrees. Rheinmetall RMG-30 RWS variants typically offer -15 degree to a +60 degree elevation. And the Turkish Aselsan Stamp Naval RWS beats all of them, with a -15 degree to a +55 degree spread. Now that's the kind of information you find on any old military-focused channel on YouTube. Here at The Military Show, we dig beneath the headlines to bring you the real story. So make sure you subscribe to the channel so you never miss out. So the Trackfire might be at a slight disadvantage compared to some of its rivals, but what it lacks in amplitude it more than makes up for in precision. It features true stabilized independent line of sight, or silos for short. That means the independently stabilized sensor module is decoupled from the weapon's axes and thus isolated from weapon recoil effects. That enables the operator to maintain an uninterrupted line of sight on the target, greatly reducing target acquisition times in the process. The Trackfire Ares' unique configuration also enables the target to be continuously lased during the engagement sequence, providing a highly accurate and comprehensive ballistic calculation, including 3D target prediction. But the real value is perhaps this. It's a modular system, designed to be configurable, interoperable, and implementable on an expanding set of platforms. There are two main units, onto which others can be plugged. The first is a director unit, or DU, which houses the sensor module, or SM. The DU connects to the human-machine interface, or HMI, which includes the gunner's display, fire control panel, control handle, and video tracker. What that means in practical terms is that the crew has a powerful visual representation of the environment and its targets at its fingertips. Operators can literally identify threats, select the appropriate response, and fire without having to break visual contact with their screens. A dual command facilitates shared capabilities, leading to even shorter response times and reduced sensor-to-shooter cycles. Plus, the system is set up for integration into other platform systems, meaning target and image data can be transmitted both within the platform and to and from others. As for the firepower it can deliver, flexibility is the Trackfire's middle name. A wide range of weapon effectors can be mounted, often in combination with one another. The Ares variant comes standard with a 30 by 113mm M230 LF Bushmaster chain gun, but it can also handle the Browning M2 HMG 12.7mm heavy machine gun, FN Mag 58 7.62mm general purpose machine gun, Mk19 40 by 53mm, and the H&K GMG 40 by 53mm grenade launchers and lighter missiles. You can also mount complementary solutions such as non-lethal effectors and jammers. In Loki's case, the suite includes a Browning M2, an FN Mag 58, and electronic warfare components for jamming. However, any of the other weapons we just mentioned, along with smoke launchers, dazzlers, spotlights, loudspeakers, and even lightweight cannons, can also be mounted onto it as required. But even the basic package gives you something most other CUAS systems don't: 2 different detection and engagement options, physical and electromagnetic spectrum tracking. This gives you multiple options for neutralization in addition to early detection. And that goes a long way to solving the elephant in the room problem for NATO: cost-appropriate responses against small, low-cost drones. Now, it's not just the cost of the materials that factor into the equation when developing CUAS solutions. The time it takes to go from idea to active in the field is just as huge a concern. The longer it takes, the more costly the end product is likely to be. In this regard, Loki must have broken some kind of NATO record. It took just 84 days to get from evaluation to delivery, an eye-wateringly small amount of time compared to most weapon systems. Loki was actually conceived as a kind of speedrun experiment to see how quickly the Swedes could evaluate and deliver a new CUAS system. And the experiment definitely seems to have worked. What began as a defense industry demonstration turned into an intense 3-month sprint to deliver a mobile, adaptable system to the Swedish Air Force's combat units. Evaluation began in January 2025, and less than 3 months later, working units were delivered, ready for testing in the field. That's genuinely quite a feat of modern military engineering. So, how did they do it? Well, according to Carl-Johan Bergholm, Senior Vice President and Head of Saab's Surveillance Business Area. Since this wasn't a typical product development cycle spanning several years, we had to think outside the box and take an innovative approach to overcome this challenge. By cleverly repurposing existing products and integrating new features and technologies, we brought the concept together at record speed. Now, having a stack of world-class components on the shelf ready to be integrated into the new system no doubt helps significantly. Of course, it's one thing to deliver a prototype, it still has to prove itself on the battlefield. And in Loki's case, it already has. In September 2025, Saab confirmed that Loki had been deployed for the past 6 months in Poland. It had been used at the Malbork Air Base, where Swedish forces from the 21st Wing and later the 17th Wing had been on NATO assignment. Their task was primarily securing Allied facilities, including a logistics hub central to the transfer of military aid to Ukraine. So, how did it perform? The official word is, well, pragmatic and understated, as you might expect from a Swedish officer. Effective air operations require robust ground protection. The systems we deployed significantly strengthened base security, both for us and our allies, said Lieutenant Colonel Christian Bertilsson, commander of the Swedish contingent in Poland. Photos of the system give us a bit more detail. Markings on the system indicate successful interceptions of 36 quadcopter-type drones and 17 fixed-wing UAVs during the radar tests. The photos also reveal the MacGyver-like construction of the system. The radar was simply mounted on a pallet and secured with elastic tie-downs. The power supply was also arranged simply and practically, with wires routed through an extension cord likely connected to a generator. Next to the radar is a red container equipped with antennas, clearly the jamming box. It hasn't been painted, likely reflecting the project's emphasis on speed rather than refinement. Now, on the one hand, that focus might present some issues for Saab as it markets the Loki around the world. The system is now being trained at the platoon level by the Swedish 21st Wing, with full integration into combat units planned by the end of 2025. But NATO integration requires a stricter set of standards, such as regulatory wiring practices. By the looks of these early models, some elements will likely need to be tidied up before they can be more widely deployed. But on the other hand, the collaborative spirit and agile approach employed in developing Loki could serve as a blueprint for future projects, or even a shift in NATO doctrine. As Swedish Air Force Chief Major General Jonas Wickman puts it, "This is a clear example of how we are building the capabilities required and that we're prepared to deviate from normal processes to meet today's threats quickly. We need to constantly evolve and find fast and competent solutions to build a stronger Air Force." Now, we don't know how much it costs, but Loki is scalable and adaptable to evolving threats, since it can be further enhanced with additional sensors and weapon stations as required. It can even operate during redeployment, providing continuous protection while on the move. It slots effortlessly into layered air defenses and is designed for expanding integrations and interoperability with other systems. How many other systems can NATO say that about? Those features could be a critical factor in the years ahead. The humble Iranian Shahed drone has changed warfare to the extent that even the US was compelled to reverse engineer it to quickly create an analog of its own. Nothing can match the power of high-end systems like the Patriot and THAAD to detect and destroy inbound aerial arrivals. But Ukraine alone could swallow an entire year's production of PAC-3 missiles in a matter of months if it could get its hands on them. Maybe the face of warfare is changing so fast that the age-old lengthy but lucrative defense production cycle just isn't sustainable anymore. It's too expensive and way too slow. In this new paradigm, it's agile, creative, adaptable, and easily scalable solutions like Loki that are likely to be the winners. We'll of course keep you updated on developments. Barely a week goes by without some exciting new development in CUAS after all. And check out this video about the UK's new CUAS system, the Dragonfire. Thanks for watching.